the Sustainability Management Master's Program, you're answering one simple question. Do you care about your future generation? If you care about your kids, their grandkids, then you care about sustainability. And a sustainability manager is someone who has the tools to make people understand how they can contribute towards developing a sustainable world. We have both part-time and full-time students. Our curriculum is 30 hours. Instead of thesis, we have a research project course and a seminar course which provides them with the kind of research background they will need to be successful in their job. But at the same time, sustainability is not always everything about environment. It also relates to the business. They will take a sustainable business strategies course. They will take a project management course. Most of these courses are going to be taught by industry people, the people who are doing sustainability on a daily basis as a part of their job. Any organization that has a large number of employees and has a physical infrastructure, they will have to have a sustainability office. If you have the passion to develop and maintain a sustainable world, come to us and we will help you shape your passion into a career which will create an impact.
The Stevens Institute of Technology is proud to present the Hugo New and Geocentric Consultants Hugo New Corporation Sustainability Seminar Series, co-sponsored by Brown & Caldwell, H2M Architect and Engineers, BEM Systems, Catalyst Group, and WSP.
Thank you, Dibs. So good afternoon, everyone. Before I get to the technical part of the presentation, I'd like to tell you a story. The story begins on February 23rd, 1945 in Iwo Jima, Japan. The greatest generation rose to the existential challenge of their time by summoning courage, a can-do spirit, and technological genius. Joining the community of free nations, they defeated fascism and created a new world order grounded in international law and lasting multilateral institutions. How did they accomplish this improbable feat against overwhelming odds? They had a shared purpose, a vision, and a desire to leave the world a better place for future generations. While there is no doubt that they achieved victory on a grand scale, they unwittingly created another set of problems. Lacking environmental consciousness, the greatest generation bequeathed to future generations a gathering storm of crises: climate change, ecosystem collapse, and environmental degradation, of which brownfields are a significant part. Across the nation, in distressed urban centers and rural outposts, it has been estimated that more than 1 million brownfield sites are being underutilized or have been left lying fallow. These hulking vestiges of our industrial past house the public memory of our nation's precipitous rise as a manufacturing powerhouse, as well as the environmental consequences of frenetic productivity. The DNA of the nation is written in their discarded architectural bones. While we experience brownfields as a national issue, it has been posited by others that the entire world is a brownfield. Therefore, reclamation, Therefore, reclamation, along with regeneration, resiliency, preservation, and sustainability, require nothing less than a global 21st century moonshot and an evolution in how capitalism is practiced. In 1962, President John F. Kennedy, a World War II Purple Heart Medal recipient, in his Moonshot speech, spoke about seemingly insurmountable challenges. We choose to go to the moon, he said, and do the other things, not because they are easy, but because they are hard. because that goal will serve to organize and measure the best of our energies and skills, because that challenge is one we are willing to accept, one we are unwilling to postpone, and one we intend to win. We, the would-be greenish generations, are challenged by the example of the greatest to raise our environmental consciousness and rise to the existential threats of our time, including the reclamation of millions of brownfield sites across the globe. So, what will our 21st century moonshot look like? Like nothing we've seen before. Rather than looking to the moon for inspiration, we will delve deep into data produced by human endeavors to change the way we perceive the world and make decisions. We will supplant the business as usual approach and replace it with triple bottom line thinking, a mindset that no longer unconsciously externalizes environmental and social costs simply because the price of doing so is catastrophic. The science has spoken, the evidence is overwhelming. We need a brave new world of smart, conscious capitalism to fund our 21st century moonshot. So, why have I taken you on a journey from the mid-20th century to the dawn of the 21st? To convince you that investors and developers can do well, really well, by doing good. To suggest that together we can deploy vast amounts of conscious capital to unlock the latent value of brownfield sites and, by doing so, create thriving and sustainable microeconomies across the nation and the world. But we must first get better at what we do. Our practices must become more sophisticated, our site investigations faster, and our cost risk estimations more accurate. Let me show you how we can use the best of our energies and skills, to quote John F. Kennedy, by leveraging big data and 21st century tools and processes. Across the economy, industries ranging from healthcare to retail are amassing vast amounts of information and analyzing it to discern patterns, make predictions of future trends, and inform strategy. According to the Urban Land Institute, real estate professionals traditionally rely on gut instinct and experience. Startup real estate data firms are changing that by amassing huge data sets and providing geospatial data streams that can inform the site selection process or identify the best and highest use for a site. The environmental industry has been slow to transform too, but firms serving the due diligence community are producing layered, mineable, geo-referenced maps for phase 1 environmental site assessment research. In the following slides, you will learn how my firm, HCI, seeks to create a central repository of data collected from brownfield sites that can be mined to produce more effective cost risk estimates, conceptual site models, and remediation strategies. Because brownfield transactions start with a phase 1 environmental site assessment, we will spend a few minutes on environmental due diligence. Let's see what typically happens when a developer, seller, or municipality receives a phase 1 report. After receiving a phase 1 report, the average client is confused. They just want to know whether the property is clean. The answer from the typical consultant sounds like this: we've identified several wrecks. And the client's confusion multiplies. They ask, what's a wreck? The cryptic answer to that question goes like this: a wreck is a recognized environmental condition, basically an area that might be contaminated. We don't know whether the property is clean until we do more testing. It's all explained in the findings and conclusions sections. Did you read the report? Understandably, the client goes into full-blown frustration mode. They just want to do the deal. But what does the report actually tell them? It turns out not everything that it should. In order to strategically buy or sell a brownfield site, a client mainly needs to know the cost and time of remediation. So, what if we could mine existing environmental data to provide an estimated cost and time of remediation earlier in the process, as early as the phase 1 stage, so that the user could strategically market a site or profitably deploy capital? Isn't it time to bring environmental due diligence and cost risk estimation into the 21st century by leveraging big data and data analytics? Let's start with how we currently do things. As you can see, starting from the bottom, we have a situation where we know nothing about a site and are unable to generate an estimate. Then we proceed to the known minimum value, which is when we know very little except for how much it will cost to perform the initial studies. With the most likely value, we usually have some data. Here, we assume technical and regulatory scenarios based on professional experience and generate the best and worst case scenarios based on an educated guess. The expected value is the most robust of the estimates and typically uses a weighted arithmetic mean or weighted average for various scenarios. So, what are the sources of data used to plug into these estimation techniques? The most obvious are analogous sites. The gas stations pictured here seem like analogous sites, but are they? Analogous sites are of the same vintage, have similar operations, are located in similar environmental settings, and are subject to a comparable regulatory framework. It turns out it's pretty difficult to find truly analogous sites. So we look to other sources of data, which include pre-existing data for the subject site, information in the literature, government databases, professional judgment, or when all else fails, a really good guess. Let's take a closer look at how to calculate expected value. Pictured here is an event tree, which you engineers may be familiar with. An event tree illustrates key issues contributing to the magnitude, sequencing, and pace of event costs and liabilities, and distinguishes between decisions, negotiations, and random outcomes. Dependencies, probabilities, and cash flows are assigned to each node, resulting in a distribution of outcomes. In this example, the expected value is 63,000, and the outcome range is 25,000 to 200,000. Monte Carlo and Markov chain simulations are more robust methods for calculating the expected value. Each non-negligible risk factor is quantified using statistical models or mathematical simulations. Risk factor dependencies are then identified and modeled during Markov chain simulations. These are then aggregated in random combinations via Monte Carlo analysis, and more than 10,000 simulations are run. The total project expense exposure is expressed in a histogram like the one you see here, which illustrates the 95% confidence interval and minimum, maximum, and median costs. We can even reverse engineer Monte Carlo and Markov chain simulations to predict time for various remediation scenarios. But of course, there's a problem. The data sources described above are not parsed and are typically not mineable for use with the robust cost risk estimation techniques. As a result, we are currently unable to effectively leverage data to inform the ranges of our cost risk factors. But what if we could deploy the power of automated processes, centralized data collection, and institutional knowledge retention software to collect and store data in a more usable form? HCI has designed a software ecosystem comprised of a comprehensive proprietary set of tools and processes to do just that. This ecosystem, still under development, retains quantitative, qualitative, experiential, and institutional data streams, which inform project management decisions, cost estimations, and conceptual site models. Central to the model is the Universal Database, a proprietary, secure, cloud-based relational database, which serves as a central repository for all qualitative and quantitative project data generated by the company. Data can be mined for a variety of parameters, facilitating statistical and trend analyses and the establishment of causal relationships. And what if our site investigation techniques were smarter and faster? Advances in site investigation and remediation techniques, such as membrane interface probe investigations, increase the accuracy of conceptual site models, cost risk estimations, and compress project timelines. We can supplement or replace the area of concern driven approach with grid-based sampling to produce 3D images of site contaminant plumes in weeks rather than months or years. Combining these two advances, what if using custom algorithms, we could rank a group of potential development sites based on real estate and environmental metrics, which can be used to inform decision-making for municipalities, developers, private equity funds, REITs, and land banks? What if an investor raised an impact fund in an opportunity zone to target brownfield sites? What if a municipality had a cost curve in their back pocket when a developer cynically offers them $1 for a parcel with a negative environmental stigma? Could the municipality receive just compensation for their land when empowered with data? What if a municipality knew what developers were looking for and ran an algorithm to rank and strategically market their sites? What if investors and developers chose to do well by doing good? The result would be to dramatically increase the number of brownfield transactions and make a dent in environmental degradation. One day, will brownfielders across the globe contribute to and mine a universal database to crowdsource the remediation and restoration of the planet? Coming full circle from the lessons of World War II to the Moonshot era to the sustainability movement, I now turn to another iconic American story to make my final point. The story of the Wizard of Oz is a metaphor for the rise of fascism in the 1930s, which resulted in World War II. Like the lion, do investors have the courage to rise to the challenges of our time? Like the scarecrow, do brownfield practitioners have the brains to deliver what they need? Together, do we have the hearts to work against all odds on a seemingly insurmountable problem to make reclaimed brownfields the building blocks of thriving economies across the world? Or, like Dorothy in the poppy fields, will we remain unconscious, seeking to maximize profits at the expense of people and the planet? And finally, how will we answer the questions posed by JFK 60 years ago when contemplating a response to the existential crises of our time? Is this a challenge that we are willing to accept, one that we are unwilling to postpone, and one we intend to win? The choice is ours. Thank you.